Yeah, let's make some noise for the next speaker. So, Career OS is investing in the new generation because it's connecting businesses and students. So the person on the stage is really important. Also because of the product and, of course, because of the deep knowledge in the technology. I'm inviting to the stage right here, Neciu, please.
Hello. Hi there. Welcome to my talk. The title is Beyond Boundaries, Navigating the Complex Landscape of End-to-End Testing. But the short title is Cyprus in Cyprus. I actually created this talk just for this joke. It's even funnier because I'm not using Cyprus at all. So before we start, raise your hand if you have actually written end-to-end tests before or work at a company who has end-to-end tests already implemented. Amazing. Now, who is happy with their tests? Did it solve your problems? Does it magically help you everything in your development lifecycle? So the official end-to-end definition is end-to-end testing is a software testing technique that verifies the functionality and performance of an entire software application from start to finish by simulating real-world user scenarios and replicating live data. Now, just looking at this definition, we can see some keywords here, which is entire software application, start to finish, real-world user scenarios, and live data. So keeping these 4 bullet points in mind, today we will explore the complexities of end-to-end testing, the tools we have at our disposals, and the problems that appear. So a bit about myself. My name is Neciu. I'm currently a co-founder at CareerOS, and I have been working as a front-end engineer for around 13 years. And historically, I've worked with all front-end frameworks. Like I've started with Angular, then I moved to Vue, and now I'm working with React. I have previously worked in advertising for big brands like Coca-Cola and McDonald's, and I also work at an e-commerce company from New York that was recently acquired by Victoria's Secret. And before my current role, I was a senior front-end engineer at Glovo, which is a food delivery company like Wolt or Foodie. And during my 13 of experience of all of these companies, I've implemented end-to-end tests in one way or another. And I almost failed in all cases because I encountered problem after problem that actually made the development lifecycle worse. So hopefully today I can share with you my failures so you don't replicate them and do better than me. So for our agenda that we're going to talk today is the happy path end-to-end tests. Where do integration tests end and end-to-end tests begin? Advanced patterns for writing end-to-end tests. And then mocking backend for our end-to-end test. So let's discuss first about the happy path. So imagine that we're working at e-commerce company. The product we built on the surface, it's actually pretty simple. We have a home page, we go to the category page, we see the list of products, we click on a product. Here we can normally choose a size or a shoe color. Afterwards, we add it to our bag and go to the checkout. Normally on the checkout page, you have to add inputs, so usually your address, your payment details, your billing information. You click continue, and finally you order your product. You get a really nice order complete screen. So this is usually a happy path that happens in an e-commerce website. And just looking at this simple flow, we identified some key pages. We have the home page, we have the category page, we have the product page, cart page, and order complete page. So our ideal end-to-end test should start from the home page and end at the order complete page. Pretty simple. Now here is an example of how we can code our happy path using a popular end-to-end library, which is not Cyprus. I chose Playwright. We go to the home page, we search for the link by name. So we search for Air Jordan 1, the category. We click on the first one we find. We wait for the header of the new page to appear. That way we know that everything was rendered and it's visible. We find the product that we wish by name. Again, we click it, we add the size, and then we go to the checkout page. On the checkout page, we find the inputs by their label name. We fill in the required data, and then we click the Save button that hopefully will show us the screen that we want, which is Order Completed page, which is the end of our test. Pretty simple. And of course, these type of libraries usually give you a report at the end where they say what tests they ran, what steps they took, in which browser, how long it took, and who and what failed. And it's pretty simple. Now, do you think this is enough for a simple e-commerce product? Are we happy? Do we go home? So it's a good start, don't get me wrong. It tests a very simple happy path, and it looks like it might catch some problems. But realistically, this test probably won't do much. And in the end, you enter this situation where you're thinking, do I have a bug? Oh, no, it's the end-to-end test that's breaking or something. So let me walk you through a hypothetical. So we have our main flow, which is our happy path, homepage, category page, product, checkout, complete. But now let's take the time to remember the bullet points in our definition. The most important part is real-world user scenarios. So let's say our fake website, our users are split between 40% new users, 60% users who already have an account, ordered before, they come to order again. So our happy path end-to-end test will cover actually less than half of our user base. And if we dig a little deeper, we can look at the data and see, wait a minute, our users don't come to the homepage. They come from Google or social media, and they arrive directly on the product page. Then from the start, our end-to-end test is completely useless. Of course, it's an exaggeration, but let's think of a bug that can actually break our production environment, but the end-to-end test will pass. So let's say in our homepage, when we hover over a product, we implement a simple fetching mechanism that retrieves the sizes and the product data from the backend, and then stores this data in the state management system or in local storage somewhere. The goal would be that when you enter the product page, you already have that data and you don't have to request for it again. So we get those details, we store them in the state management, and when you go to the product page, the developer implementing this actually forgot to check if the data exists or not. So he just takes the data from the local storage or state management system and maps through the sizes. Now, with our end-to-end test, this will be green, because the end-to-end test goes to the home page, goes to the category, reaches the product, so it will have the data in the product page. But real users coming directly to the product page will see like undefined, you cannot map on null or something. That means for almost half of our user base, this page will fail and our users cannot order. Orders go down, we notice it after 2 hours, another 2 hours pass by until we identify the problem, fix it, or revert the commit. By then, we already lost 10% of our daily income. And remember, the chunk of our user base, the 60% of returning, don't actually even use this flow. They can just order from their wish list. So our end-to-end test is not even taking them into account. Now, of course, my example is an over-exaggeration, and in real life, things are rarely that simple. So obviously, a developer will notice this. But if it's just a small attribute in a backend response that we might assume it's in local storage and it's not, you'll probably get that dreaded property of undefined error in production. So now let's see how we can improve this, how we can use integration test logic to help our end-to-end test suits. So we already can see the problem. We have a pretty simple website with a clear flow, but there is no easy way to define start. Because our users can enter the home page, but they also can enter the category page, the product page. Even more, users can probably order directly from email now. They have a button that says add to cart, and it immediately takes them to the checkout. So with so many entry points in a e-commerce website, it's very hard to define what the start and finish is. So what do? Do we write for each use case end-to-end test? For every possible start position? Let's try to do something different. So instead of having one test that's covering the end to start of the whole big flow, we create smaller tests with a clear start and finish. For example, we have homepage to category page, and then that the test is finished. We have category to product page, and so on. This way, no matter what the overall entry point is, we make sure you can reach the next step correctly. So these are still end-to-end tests, but we narrow down the ends. We're not mocking anything, so it still satisfies our conditions. We're testing the entire application, albeit in pieces. We're testing from start to finish, but we redefine the start and finish to suit our needs. We're still using real-world user scenarios, and most importantly, we are using live data. So here is a typical example of the homepage. Just as before, we're entering the homepage, we expect the page to have the title, we get the role by the name, which is Air Jordan 1, and then we click it. This will take us to the category page, and now the test is finished. We do the same for the category page. It starts at the category page, we give it the category page link, and then we do the same steps until we reach the product page. Similar to the product page, we do the same thing. It's the exact same test as before. We just now finish at the checkout. On the checkout, it gets tricky because usually if you go to the checkout directly, there's no data there. You need to probably do some steps beforehand to have data. So here we'll probably need to implement some test data builders and test data destroyers. But this is a problem from later. So we went from having one long end-to-end test to having several, each part of the whole. And by breaking it in different files, we can assign clear ownership to tests. Because when you have one big test from homepage to checkout, who's going to maintain it? If you have like 6 teams working on the front-end application, who's responsible for the end-to-end test? But now, if you have multiple, each with a clear page, the team who's responsible for the homepage is also owning the end-to-end test dedicated to the homepage. And looking at our user base, now regardless of the entry point, let's say we have 20% are new users coming to the homepage, 23 to the category page, 30 are returning, they're coming to the product page, checkout. So we have all of these scenarios covered. We know how to get to the next point. Now this is imperfect, of course. It's not that reliable. There are things that can happen between pages, like redirections or bugs in the state management system that will still break. But we need to set up, like I said, for checkup, the data builders and data destroyers. But having tests split like this will make it easier to maintain in the long run. So we already split our test into specific pages. So it's only natural that our first pattern that we're going to discuss today is the page object model. So page object models is actually one of the most successful design patterns in test automation. The main idea behind them is to encapsulate all the page logic inside a big class, let's say. So for our homepage, we can have the homepage page object model. And here we find everything we need to create our homepage related tests and abstract any logic related to the library you use or the attributes you are using to create the homepage test. And by having everything in one place, it simplifies test creation, maintenance, and again, ownership. So let's see how we can implement this. Here, this is what we had previously for the product page. We waited for the heading, we chose the size, we click Add to Back button, and then we wait for the label Add to Back to appear, and this will take us to the checkout page. And the success of the page happens when the checkout page heading appears. So the plan is to abstract everything related to the product page to the product page object model. This means that all the attributes, getters, finders, and all the event triggers. This is basically one big class that encapsulates all this logic. And one big benefit for this is that it becomes future-proof. So for example, if you want to change your testing library from Cyprus to Playwright or Selenium or whatever, you have all the library logic in these page object models, and the tests don't actually care about them. Or even if the future you update your version from version 14 to 15, and it has breaking changes, like you no longer have the get by role function that the library has, you just change it in the object models and not actually in the tests themselves. And here we have the methods that simulate user actions. Again, this is in the product page object model. So we, like going to the product page itself, if the URL changes, we can just update it here and don't touch our tests at all. So going to checkout, adding a product, adding the bag, everything is in the product page object model. Now the test itself looks like this. You initiate the product page model, you tell it, go to the page, you ask it, is the product page ready? Then you do some actions, add to bag, go to checkout, easy peasy. Now, once you write it like this, the maintenance no longer happens in the test itself, it goes to the object model, and it's actually more readable. Anybody can read this and understand what is happening. Now, one downside of the page object model is that it gets bloated. And you will have to test, you have to combine multiple POMs in a specific test. Like we saw product page, then it reaches checkout page. So we need to combine two object models to have the test work. Now, the screenplay pattern in contracts is like you're directing a play. Like each actor knows how to perform specific tasks, like logging in, searching for a product. And it's more flexible and dynamic than POM because it focuses not on pages, but on user interactions. So we have this, we're the director of a screenplay. We have actors who are the main entities or users, and they represent the different types of users who interact with the system. So each actor is responsible for specific tasks. So we have an actor for new users, we have an actor for returning users, we have an actor for customer support, we have an actor for VIP users, and so forth. Then we have interactions, which are the actions the actor performs. For example, let's think, a question, it's like, go to a page, this is an interaction. Click a button, this is an interaction. And then we have questions, which are used to retrieve information from the system. For example, a question could be to retrieve the text from an input field, or if the last added product to the cart is what we expect it to be. So an actor is, we define the user, then it interacts with the app, and then the actor itself asks the questions, hey, is the last added product what I'm supposed to be? And then we have tasks, which are an array of interactions, multiple procedures added together. So, for example, you saw when you add the product to your cart, you first have to choose a size, you have to choose a color. All these together represent a task that you give to an actor. And finally, you also have abilities, which are basically permissions. So you might want to test that a normal user cannot add 3 products bundled. That's just for VIP users. So you have these abilities that are restricting your actors. So what's good about the screenplay pattern is that it works perfectly on top of the page object model. It's mostly a framework on how to make how to take actions in your test that are more business friendly. So we create our actor, which is returning a user. We tell the actor to perform add to new product to cart, and then we ask a question. Is this the last product added? If the answer is Air Jordan 1, then that's complete. And the good thing about this pattern is you can abstract everything. You build it once, so you create this functionality of perform, user.performs, and you use it in all of your tests. So you create common interfaces for all of your POMs, let's say, and then you use this system all over the app. Now, sometimes we want to test specific flows based on some config data. For example, we want to test if we are on mobile or on desktop. Do we use the same test or do we create different tests? How do we do this? The page is different. We probably have different attributes on mobile than on desktop. We have different buttons, different text. So we can create actually a factory class that basically creates our POMs for us. So we don't know what's happening behind of the hood. So the idea with the factory pattern is to reuse the same test cases, but initiate different classes. So based on viewport size, if it's mobile or not, we just tell it to the model factory, and then we just use it. We don't care what happens. We don't need to know what the factory is creating for us. And in the factory, for this example is just a simple if-else case. But we abstracted everything in the so we have two object models, the mobile and the desktop. Both of them are actually an extension of a base product object model. So we create a base, we extend it, mobile, desktop, and then we let the factory decide which POM to create based on the config file that we give it to it. So, simple conclusions. Use the POM pattern to abstract page-related attributes into a single file. Use the screenplay pattern to write business-friendly tests and abstraction common interfaces for actions and questions. And then use the factory pattern when you need to create different test pages based on config data. Finally, we reach our most controversial point, in my opinion, mocking the backend. Now, I'm not going to show you any more code. Now we're going to talk a little bit more on, let's say, hypotheticals. So who here has done this? Don't be ashamed, I did it. It's fine, it's fine. So you might think there are no reasons for doing this, right? But I can list a number of reasons. First is server costs. Every time you have a front-end PR, you want to check if it breaks critical end-to-end flows, you need to boot up a backend to do this. And it can get pretty costly if you have like 100 PRs per day and you have to create a server for each of them. Secondly, let's say you don't care about cost, you have infinite money, but the fact that you have to wait for this backend to boot, for the Docker image to be fetched from the repository, to be built and deployed, it might take you 10 minutes just for the backend to be booted. But let's say you don't even care about this. You have a staging environment already set up that your test always tests with the staging environment. But every time there is a backend PR, it can break. If the staging environment is down, then what happens? You can't merge anything in the front end. This used to happen to us a lot. Like the staging environment is down, time to go to lunch. Now finally, let's assume all these three issues were avoided. There still comes a point where your end-to-end tests are way, way faster than the backend returns the data. There's networking issues. Maybe your front end are hosted in Europe, your backend is hosted in the US. This can get really problematic when you have a server-side render app and your testing library is trying to click on buttons, but the app is not fully responsive yet, it's not hydrated. So given all this problem, should we do it? Should we mock the backend? Yes, no? No? Yes, no? I guess there are some people who say yes, some people who say no, some people don't care, probably PHP developers. Every time I talk to them, they're like, I don't need to write tests, I have God on my side. So actually, this is what we did at my previous company at Glovo. So we decided, because there were so many good reasons to do it, to mock the backend. And we said, okay, here's how we're going to do. We're going to have contract testing in place. So between the backend and the front end, we're going to agree on a contract. On every response, it should have these types, and you're not allowed to change them. For each backend PR, It ran against the contract and tested that there are no changes, which sounds amazing in theory. And if there's a change that the front end does not approve of, that's not in the contract, the backend PR would fail. That way we avoided backend responses changes. Like the most common problem that could occur is when an attribute returned null instead of an empty array, for example. And then our JavaScript maps will fail. Now, secondly, the first time the end-to-end test ran and it hit an endpoint that it got 404 on the mocked version, it will actually call the actual staging environment endpoint and record the information in a JSON. So in future runs, it will use the cache JSON, and that way we always fall back on real requests if the mocked request failed. Now, like I said, we were serving data from JSON, which made the app really, really fast and allowed us to run all our end-to-end tests in parallel. And that meant that the timing it took to run all 50 end-to-end tests, it just was the longest time of the longest test, basically, which was 2 minutes. So our entire pipeline, which had different types of testing, like we had unit test, end-to-end test, integration, and visual test, it took 5 minutes for each PR, which was pretty fast. So do you think this solved our problems at Global? Yes? So it was actually a pretty big failure. The number of bugs hit in production has skyrocketed since then. So the worst part is it became a hassle to maintain the end-to-end tests. It was like having a different project we were hacking just to get the end-to-end test to work. And it was not actually checking functionality. And because we were mocking the backend, we hard-coded some content. Like restaurants, we created end-to-end restaurant, end-to-end product. So we always had that content mocked, and it didn't actually check when there was a new feature. So for example, we added a rating system in our restaurants page. Because the end-to-end test were using mock backend data, and that attribute didn't appear in the endpoint, that feature didn't even appear in the end-to-end test. And if there was a bug or something in that, it will just happen in production. So we were aiming for having the happy path tested, but instead what we did, we gamed the system. We manufactured our entire end-to-end testing environment, and sometimes it worked, sometimes it didn't, but it never caught anything that happened in production. So the reason for that, we forgot about the most important part in the end-to-end definition, which is the live data. If we're not testing using live data, we're not doing end-to-end tests, we're just doing fancy integration tests and with some extra complicated steps. And I have to say, the best end-to-end test I have actually written was working in production. So every day at 6 o'clock in the morning, the test would boot up, would go to the live website, it would order an actual product, we'd put the address of our office, and we will receive the product the next day. Using this test, we can even check the delivery times and see how fast things are happening. And then we had another end-to-end test that was returning the product to just see if our returning system also worked. And it also helped us when we broke production late at night because we were different time zones. So if someone in Europe broke production, it actually, before New York woke up, it will test the end-to-end test and see, hey, the app is not working, fix it. So let's recap what I've talked about today. So have small page-to-page end-to-end tests, use POM when defining tests, so you have maintenance in just one place. Never mock the API, it's not a good idea. And the best end-to-end test is actually one in production that actually works. And of course, look at your user base, see where they're coming from, what are they doing, and write end-to-end tests for that. Efaristo.
Your questions, please. Raise your hand, ask the question.
Yeah, thank you very much for the presentation.
Yes, start with a smile.
On the slide, right after the screenplay, you used objects as a way to describe actions that need to be taken. Why do you use this object model instead of just calling the methods?
You can. I just wanted to show that you can use both patterns at the same time. You can use the screenplay pattern and the POM pattern together. But, yeah. Did I answer your question?
Why is it better?
Why is it better
Yeah.
to use them? Well, it's not actually better. You can use just the POM system at all. Yeah, it gets more complicated if you have both at the same time. Historically, I would say it's better just to abstract the library-related attribute getters in the POMs, and then you can build the screenplay pattern using the interfaces like performs, questions, asks about, which is not related to any library.
Okay, thank you.
Thank you.
Thank you. More questions? Good.
Thank you. Hello.
Hello.
Help me polish my understanding. So you told about POMs. My question is these POMs the code base of tests, or it's a part of the production code and you just input it in tests?
So they should be in the same repository as the application you're writing. At least that's how I used it every time.
I mean, the main model, the big class, as you said, is it the part of production code, or it's a part of tests that import some smaller functionality from the main code base?
No. It should be about production code. So it should just look at attributes that would be in production, like class names, button names, stuff like that.
So in production code, you also work with the POM, right?
Yes.
Thank you very much.
Hi. Thanks a lot for a great presentation. My questions regarding your third conclusion, never mock the API. Do you notice any disadvantages of writing tests on production environment?
So writing tests on production environment.
Yeah, maybe the speed of development was forced.
This is one. The best, I would say, the disadvantage would be obviously if production down, also end-to-end tests are down. You need to have really good test runners so you can filter them out of data analytics, which is a hassle, because if your bots are clicking everything, then you will assume, the users are doing this as well. Maybe they're not.
The thing is that once you are using mocking API, you can easily provide the preconditions for your UI tests. And once you start to use production, it becomes really worse, and you just need to implement a lot of infrastructure around your UI tests. So this.
If you're mocking the API, yes.
Not if you are using the production. You have to provide the infrastructure for your UI tests. Like if you are trying to run it in parallel, and you are aware that your tests can affect each other because you are using real data on production, so and stuff like that. Maybe.
Yeah, this is the point about test destroyers and test builders. What we did actually when we were testing production, we never created new users or new addresses or nothing like this. So we had a specific user, the end-to-end test logged in with that user, and then it actually used everything that a real user should. Yeah, we did have a pretty good infrastructure when we did this. So we were running everything in Kubernetes. It was super fast. But yeah, it is a problem.
Thank you. Please.
Hi, thank you for the talk. Yeah, I wanted to ask you about this POM model. Like when you were talking about this thing, it just blew my mind because it's such a big, like you basically repeating the same thing what is like under the tests, like you doing your classes, like methods or whatever. It's just like such an excess, additional work. You know, like would you consider to use the existing methods and classes maybe to substitute like this? You know, this when you ask for give me the title, everything, just maybe you can substitute it to the existing classes and methods of the existing model, because it's such a difference compared to the unit tests, right? In the unit tests, you just use the methods that you have, and here you write everything again. But
Yes.
it's like a lot. It's just crazy.
It is, yes. But the benefit is that you don't have, hopefully you don't have to maintain them. You write them once and they never change. Obviously they do and you have to maintain them, and it is a hassle to, because when you write the end-to-end test, you need to use user-friendly data. Like you can't just import the button from your React application and click it like you would do like for an integration test or a unit test. You want to find it in the document using the button name or accessible related roles, and then you have to rewrite everything basically. Usually there are people that just do this. So there are test engineers who actually just write the tests in different companies.
Click the button.
Yes,
Yes, please.
Hello, hi, thanks for a great topic. I'm really excited to ask more details about this real-life test with ordering to the office. I understand and admit that it's like real-life tests are much better than mocking up the API, but as much as I understand, when you're mocking it up, you have more like varieties to check. And you, on a production, you really, I guess, you have like one address, one user. I guess this is really one product, like something teeny tiny, or I don't know how. Can you share like the other disadvantages that you meet when you started to implement the real orders instead of mocking up? Thanks.
So we decided not to cover every test case. We decided, okay, for new users, people, we saw that they arrived directly on the product page because we did marketing campaigns, and we wanted, okay, for these that were paying money, it costs us $20 to acquire one new user. For them, it has to work. If they have reached the page, when they click this button, it has to work. So this is what our end-to-end test was covering. We actually did all three things. So we had this one happy path test in production. Then we had not mocked, we had a staging environment which connected to each staging microservice. We had, and this was, so you went, backend PRs did not merge into this. We were using, what was it called? Git flow. So we had master, develop, and it was using master, and basically we were doing 2-week release trains into master. That gave us time to prepare the staging environment every time. But it was pretty hassling.
Oops. Oh yeah. How often did you change this happy path that happening on the production? I mean, did you choose it once and it's been working all the time, or you constantly like, oh,
No.
we should edit? Or
We never changed it. So we built it once, and then not once changed it.
Nice. So you knew from the really beginning.
But
what you wanted.
to say it, because the reason we never changed it is the checkout page in our app was using old Angular 1 code that nobody wanted to change. So the front end was not changing.
Got it.
That means the end-to-end test was not changing,
Okay,
which
thank
was super lucky for us.
Thank you so much.
Thank you.
2 more questions on both the last rows. Nice.
Hello.
Hello.
Thank you for the talk. This statement, never mock the API, sounds pretty decisive. Would you consider doing both ways in your project for somehow checking majority of the cases with the mocks APIs and making some real requests as well for the later stages?
Yes, so this is what they did at Glovo recently. So they went from this hybrid model where they would use the most, so they analyzed the APIs. They saw that 80% of them were not changing at all. They mocked those, and for the 20% that were changing, that teams were actively working on, they decided to use staging data for that, and it got better.
How would you describe the percentage of the mock APIs and the real ones in this case?
Sorry?
I mean, how would you decide the percentage? How much tests would go into the mocks and how much into the real APIs? Or like 10/90 or 50/50?
No, they looked at the rate at which the APIs were changing. So if an API, let's say /products, serves the same information, there are no new keys, no new attributes, it doesn't change everything in the types, then let's mock it. If an API actually is more important, like the product page, because we always improve the product page. We add ratings, we add new data, new tabs, whatever. So that was constantly changing. We had a dedicated backend team just for that endpoint, then we will not mock that data.
Makes sense, thank you.
Before we pass the microphone, please rate the talk. Please scan the code, give some feedback, so that we can for sure invite Dan again the next time. Please.
Hello, thanks for the talk. My question is, what testing framework are you using, or would you recommend for front-end frameworks?
So I use Playwright for this talk because I've never used it before, and I want to see how it is. Historically, we've always used Cyprus. We found that it was, I mean, it's the oldest one, and it has pretty good track record. They got caught recently doing some shady stuff. Like they are checking in your NPM packages if you have installed another package that is related to end-to-end testing, and then they block it. I don't know, there was a huge scandal, so that's why people now are switching to Playwright. Playwright has Microsoft behind them, so it's a Microsoft software. It actually runs in all browsers. The team that is behind it, it's actually very, very smart. Yeah, going forward, I would choose Playwright. Seems to be newer, and it's in the direction we want to go in the front-end application.
Are you okay to take another question?
Of course.
Please.
Yeah, hi, thank you for a great talk. So my question is related to running the tests on production. So do you run all the end-to-end test cases on production, or you select a subset of it? Because one problem would be generating a lot of data, and I mean, sometimes it's not a good idea, or maybe it's not allowed to do that. So how do you deal with that? And when you generate that data, let's say, how do you like roll back, or what's the approach to it?
Yeah, so we just ran one end-to-end test, which was not actually part of the front-end repo. So what we did in production is we created another project, which was end-to-end production, let's call it. We actually had a cool name like Jarvis or something. But so that ran just one end-to-end test, and it didn't run at PR changes. It ran just once every morning at 6 a.m. It was like a cron job that you scheduled.
You will get a lot of final questions today.
Yeah, one more question. You told about splitting the global E2E test into smaller ones. And then you told about the buying some shoes from the Nike, or I don't know. I can't understand how this global order and return process was tested if you split your end-to-end tests into smaller one.
Yeah, I guess my mistake was we didn't use this. So the splitting became part of the application test that ran at every PR. So at every PR that we built, we change a feature in the front-end application, we ran all these tests that takes you from this page to this page, from this page to this page, this page to this page, which were 100 tests, let's say. But the production test that I said that happened only once per day was a different project that didn't run when you change something in the front end. It just ran at 6 o'clock in the morning, and this one was like a long end-to-end test that we did before.
Thank you, Dan. It was a great presentation. These applause are for you. So we have more than 20 minutes till the next talk, so then we'll be in the discussion zone right outside the hall. And one thing I need to say, we're making history here because I'm hosting conferences for more than 10 years, and it's the first time when we have the parents of the speaker in the hall. Let's give them a big round of applause. Thank you for your smart boy. So guys, check out the program. Make sure you're in the right hall at 12:20, and have a nice day. Continue networking.